Good morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Aptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Happy Thursday.
It is a happy Thursday. It is a wild and new Thursday, Mr. Zane.
It is. Good to see you, Rose.
It is very good to see you as well. Thank you, sir.
So I'm assuming you saw some press release today?
I know. This is very, very exciting. And I imagine that we're definitely going to have some questions from the world, specifically the Linux world, on like, what does this mean? What is it? What is actually happening? So yeah, give us a couple of details, just overarching.
Sure. So high level, well, you can read the press release. There'll be more coming out about this in the future, but in cooperation with Oracle and SUSE Linux, CIQ has entered into a cooperation where we're going to actually have the Open Enterprise Linux Association. So Open ELA. That's what it's going to be called. And that's going to be a place for Enterprise Linux to have a standard for everybody to pull source code from to actually go build your compatible Enterprise Linux distributions. Very exciting. It's a great thing for the community, and I love seeing this. I love having these large companies involved with us and helping us do this. It's very exciting. So thank you to Oracle and SUSE.
Thank you, CIQ, Oracle, and SUSE for coming together.
Absolutely. It's fantastic. It's really exciting.
It really is so cool. So if you guys have any questions about that, you can go to our website, or you can just go to the openela.org. And there is a lot of information there. You can join the Slack channel. You can join the movement. You can ask questions, all the things. So very exciting. Very happy to have you all.
That is not what we're here to talk about today.
No. We're actually going in a little bit of a different direction, sort of, because that kind of like, having open enterprise Linux, right, available kind of supports a lot of what we're going to be talking about today. Specifically, we're going in the direction of harnessing AI, machine learning in high performance computing. And so we're going to get into the details of that, but I think we have some friends here. Are we adding some other people besides us? Yes, Alan in the house, Mr. Jonathan, Forrest, very excited. Thanks for being here.
Hello. I simply came to this one because I know how much Alan loves this topic, and I actually thought about bringing popcorn. I'm looking forward to this one. Welcome, Alan.
Hey, no, it's nice to see all of you, and I'm just here to keep you guys in line.
See?
I love it. I didn't realize. Thank you, Alan. I need you. Can I, are you for hire to come to my house too and keep me in line the other days?
Yeah, no, it's a great topic. It gets a lot of discussion. Why don't you introduce the topic, Zane?
I'm sorry, Alan. I missed what you said.
I don't think we know what we're talking about yet.
We are talking about AI and machine learning and HPC.
Okay, great.
Your favorite topic. See?
Yes.
Not as much what you think about it.
You just joined anyways. Whatever you guys are talking about, I love it. Let's do it.
I love it.
You want to introduce the others and we can launch it?
Absolutely. Forrest, I feel like it's been a minute. How you doing?
Great, Zane. It has been. Can everyone hear me all right?
Can.
Wonderful. Yes. Thank you, Zane. It's good to be back. I've been out of the office for a little while, but yeah, excited to be back in this week and excited to once again be here at the roundtable.
Thank you, Forrest. Jonathan.
Hi, everyone. My name is Jonathan. I'm a solutions architect here with CIQ and know a bit about HPC, a little bit less about AI. So I'm also eager to hear more opinionated AI voices in this conversation and participate as best I can.
Alan.
Okay, well, I was hoping we'd get more. We have had some fantastic people on this table over the last few years, and I was hoping you would pop in. So this is, of course, buzzword compliant topic. And we're moments away from the mashup of quantum and AI buzzwords. So watch for that to appear on your screen shortly, right? Quantum AI startups are just around the corner, right? So what I think I'll go back to exactly what you said, Zane. What do these terms mean? What do we mean by AI? Do we mean deep learning? Do we mean generalized sorting algorithms? Do we need generative learning? Do we mean linear regression? It's all linear regression, by the way. Do we mean predictive language models? So I think the first thing we can do as a community that would be beneficial to everyone is the old high school debating tactic. You could always bring the other team to its knees by asking them to define their terms, right? So what do these terms mean? So I'll just throw it right back at you guys. What do you mean by AI? What are you seeing it play out in the marketplace as? Let me ask it that way.
It's a great question, Alan. Thank you for that. So it's been fun, guys. I really appreciate you coming. We don't really have anything to debate anymore. No, I'm just kidding. I'm going to let Forrest answer this because I feel like whenever we start talking AI, I typically default to Forrest. He spends a lot of time on this topic. He enjoys this topic. So my opinion, Alan, is it's all of those things. I think it depends on what part of that thing and what part of HPC are you looking at doing at that moment in time. So I feel like this could just be a never-ending conversation, but I'll let Forrest have at it.
Overall, I would say AI is a pretty broad definition in general. Like you said, Alan, are we including these, kind of sophisticated, framework-based AI models that are built on something like PyTorch or something like that? Or are we looking at more, the use of mathematical models? Like you said, it's all regression in the end. I tend to define AI as being the genuine creation of one of these, model-based architectures in some type of framework. So whether you're building, one of these perceptrons, one of the more modern types of, large language model, GPT type things, I kind of overall just refer to AI as that catch-all of these specifically built, usually layered to some extent, neural network type architectures that are a little bit more than just taking a bunch of data and applying, a few different statistical models to it and kind of seeing, what you can predict with that. Overall, I would say AI comes down to having that, neural net-like architecture where you actually have some type of, you can go really deep with this, but, you've got activation functions, you've got neurons, you've got 1,000 different ways that people do that type of thing. So overall, I kind of, look at AI as that layer-based creation of some type of potentially autonomous agent trained on a specialized corpus of data for some type of purpose such that it can make informed decisions on its own. So that's kind of what I would say. As machine learning is a little bit, included in there is more so, I would say, on the statistical side of things than it is the creation of artificial intelligence. But I know some people kind of lump those a little bit more together. I've kind of found in general that's sometimes a gray area. But for me, AI is neural nets, the GPT type things, these sophisticated agents that are meant to take in some amount of data, learn something, and give you a more sophisticated result than just, basic statistical modeling.
Jonathan.
Yeah, so I'm with Forrest about AI. AI is pretty broad. And I think of these as viewed from different perspectives. So to me, AI is most useful as a catch-all term for a user experience than any particular technology or field. it's computers that are trying to interact with us, with the users of the computer, like another person would, let's say. So you're talking with an AI chatbot, and your experience is more similar to speaking with another person than you might otherwise expect from a machine. Things like that. I'm a systems guy, so where I look to these terms is to help me differentiate different parts of systems architecture. And so my definitions are less accurate than they are useful to me. So when I think of HPC, like if you just pull that term apart and you're like, any high performance computing system, that's not useful to me. But when I think of HPC as that culture of computing that grew up in the kind of national lab space and the university space that kind of distilled itself down on something akin to a Beowulf model with a high performance interconnect and MPI, things like that. That's what high performance computing is to me: is distributed memory, fast interconnect, running a process across multiple system images. And so for me, when I think of machine learning, I'm less concerned with the actual machine learning, the application, and more they're the guys who actually use the GPUs I installed. And so that's most of where it begins and ends for me. They're also the guys that tend to fill up my storage, but then don't use my interconnect. And so that's where it breaks down for me, is less like, that's not a useful definition of machine learning to anyone except for a sysadmin who draws the line at, well, the application does something, but what I know is it makes the GPUs get hot and fills up my storage.
It's great.
Okay, Alan.
So, I think there's so many directions. Thank you. Those are the answers I wanted, and I think they're accurate. The problem I think we have to face is that we have to be aware of the fact that we're the folks with a hammer, that in the proverbial, when you have a hammer, everything looks like a nail, right? Some people come along and say AI, we say HPC, right? So, you want HPC? So, we have to be sort of careful what they want. What they seem to want is machines that think, and so this leads me to what Zane was expecting me to say. My oft-repeated, but I think still accurate statement that there is no AI. There is only obscure scripting with unexplored failure outcomes. The problem with that statement is it doesn't make a really good marketing T-shirt, right? So you can put it on a T-shirt, people would probably buy it, but
we've made freeloader T-shirts. Surely we can put
yeah,
that on
that's right.
T-shirts.
You guys are the experts in this.
I'd buy one of those. I'd be rocking that on the daily.
Okay, so if you talk to this from the sales, you talked about different perspectives. So from a salesperson's perspective of hardware, software, operating systems, whatever, it's what would you like it to be? What's AI? What would you like it to be? Right. So there's the famous Dilbert comic strip. I try not to quote Dilbert much these days for various reasons, but I can't ever forget the one where the pointy-haired boss meets with Dilbert and his colleague and says, we've just gotten our consultant report and he's identified our biggest problem. And Wally says, I recommend we build a tracking database. And Dilbert says, we can put it on the network. And the boss says, would you like to hear what the problem is first?
That's awesome.
We're sort of in that situation. What would you like it to be? Well, and the reason is it is a set of technologies, not a single technology. Sorry about that. So I'm just going to let that ring and let the rest of you talk. I'll just point that aspect out, and then we can. Oh, Fernandez here. Good. So
yes,
maybe we can talk a little more technically about what are the ingredients of AI and why we end up applying HPC to them. That would probably be a useful direction.
Thank you. Welcome, Fernandez. It's good to see you.
Hey. Hi, everybody.
Hi.
I'm just listening. I don't know what's happened so far. I was double booked.
No, it's fine. So we're kind of discussing what is everybody's view of AI, ML when it comes to HPC. So what does that mean to you?
I mean, I think it's all HPC now. I don't think you can extract or differentiate HPC from what's happening even in the broader workloads. So they're all scaling now. They're all using GPUs. They're all doing really large data sets. So I don't think there's a difference between AI and HPC, because I think it's all becoming HPC.
It's very interesting. So one of the topics I know, Forrest, you and I talked about this quite a lot at SC22, and we spent some time with a group who was doing a lot of data collection that we talked about. Wouldn't it be cool if? And I know, Alan, you don't like this topic either. That's why I'm going to talk about it. Having AI actually watch HPC infrastructure and stop problems before they happen, or help prevent things, or make changes.
I do like that topic.
Okay, so in the past, I thought we'd talk about not liking that.
No,
didn't want AI.
I don't think
that,
we're there
I think
yet.
that was me.
Was it Jonathan?
Yeah.
Okay.
Yeah.
My apologies, Alan.
No, I think this is a great topic, and my my take on it in a sentence is, I don't think we have enough information and we've been shy about getting it. And so a lot of my work in our industry university cooperative research center has been drastically expanding the amount of monitoring information we get in a useful way. We had a supercomputing talk. I'll put a link up. But yeah, 2 or 3 orders of magnitude more information from the baseboard management controller. So you can do things like watch memory power and CPU power separately on tiny fractions of a second time scales without ever instrumenting your code. What we work, what I like to say is, we work on precursors to AI. You can't actually do, anything really intelligent if you're only monitoring something once per second, right? Then the question is, what do you instrument and how do you get the data in modern clusters? Yeah, so I'll find a link and put it up.
Thank you. Forrest, I don't know if you remember when we went and spent a little bit of time having this discussion, and the amount of data they were collecting. I feel like it was like 66,000 pieces of data they were getting every second, something like that.
It was some per minute gigabyte rate.
It was a lot.
Shocked to see or to hear about.
Yes.
Yeah, I agree with that one completely. Just like you say, precursors to AI, the biggest, we have the model and then you have the data set, and one isn't particularly useful without the other. And so without, some massive corpus of data to actually look at that, like Alan says, gives us, high granularity of what actually happens on a system that some type of agent can look at, try to determine trends from, learn how to optimize a system based on. This is kind of what stalled AI in general, as I understand, for a while. ImageNet and things like that were very big because they were some of the first times where people had collated all in one place, large, for example, tagged data sets of images and things like that people could just go and use for AI. So when those kind of things started to come around, we kind of saw this explosion of, image recognition and things like that. And so, yeah, I completely agree. There's a lot of metrics and data that are left to be able to effectively collect on a system that we would need to have extremely large amounts of. I mean, the basic corpus of data that the GPTs are trained on, they call it the pile, which is this big, huge bunch of like random web, like Stack Overflow, Wikipedia, stuff like that. I think it's like 770 gigabytes or something like that. So you can imagine, in flat text, if we can find interesting ways to compress down, the specific types of data that we're pulling off of an HPC system, you can imagine, the sheer amount of data that we would end up with there at certain levels of granularity. So, yeah, a huge problem at the moment is there is no massive kind of organized corpus of metrics and data and things like that something could actually look at and be trained over.
Yeah, in addition to the link that I supplied, there's the toolkit called Like I Know What I'm Doing, LIKWID, Liquid. And that group has put together an astonishing variety of tools and features. We're working with one of the vendors on instrumenting MPI code in a more natural way. again, without interfering with the code. You don't have to compile anything, and you just use Linux perf and MPI tracking. And so we can do things like, many of the things you'd have to normally dive into TotalView and do. So let me wind back though. My criticism about AI is that, and the reason I say it doesn't exist is that what we have in general are things that can be trained. Everyone feel free to disagree with me, but they can be trained on pre-existing data or models and used to predict the next most logical outcome. In the case of languages, you predict the next most likely phrase or sentence, whether or not it actually makes any sense. So there's no thinking behind it. That's my criticism. Same thing with art. You can train it and it can make art, but it's basically just plagiarism as a service, right? So, so I don't think we are anywhere near actually getting machines that think. But going back to what you said, Zane, I think that problem is highly approachable. Machine learning-based steering of computational codes has been a positive influence on those codes in a long time. Think about minimization algorithms. You can write something to try to approach minima, or you can throw machine learning at it. And the latter approach, when you have those constrained problems, it's eminently sensible. People write code with AI these days, and we even have a whole major repository framework that does that, steals your code and gives it to other people. But
I want to come back to that, Alan, because I think it's an interesting topic and kind of diving in a little bit to what you were doing and having to not instrument code. But I want to get Fernanda's opinion on this too. Are you comfortable letting AI make decisions on your HPC cluster?
Not if it's a production system. If it's a research system where a few jobs get lost and they have a 24-hour cap on running, sure. If it's something that I'm running some week-long computational chemistry code, or running something that makes planes fall out of the sky, then no.
Oh, I agree. I don't want that either. So I think we do have a couple of questions, and I'm going to go back to Alan's.
If I can touch on something Alan said there really quickly.
Yeah.
I just wanted to mention that, especially coming up on a year post ChatGPT release, it has become incredibly apparent that these systems are not the dynamic answering engines that we perhaps anticipated them to be at the start of it. But there is a lot more of just kind of the prediction of the next most likely word in the chain. Essentially, people have seen kind of the quality of some of these major AI systems, like it can't pick out prime numbers and stuff like that anymore, versus versions of it that were out months and months ago. And they are completely unable to solve the problem of hallucination in the end, even with all the resources and time and stuff that these places are putting into it. They are unable to stop it from just making stuff up at random. So it turns out
it's unsolvable. Yeah, I think it's completely unsolvable.
Because in the end, just like you said, Alan, it's not. This is not machines thinking. It's just some agent predicting what the next most likely thing in the chain is. The big misconception is that these things don't know anything. They just know what a lot of people have said about something in a certain case. And so, yeah, I just wanted to say I completely agree there. There's not really genuine thinking. It's sophisticated Markov chainers and stuff like that. Essentially, in the end.
Yeah, you could point that criticism in both directions on the AI-human boundary, right? You have to keep in mind that the stuff that we're being trained on comes from us, and we're not exactly a source of truth ourselves, right? So,
thank you.
True.
Well,
I was gonna say,
present company included.
that's the way that I think. I don't know how you think, but I only have access to what I have, seen, heard,
We are a
read.
source of chaos.
So we do
We're
it.
not a source of
We
truth.
do it already. I mean, we've been writing script. I said it's obscure scripting with unexplored failure outcomes, right? So we've been doing, hopefully a little less obscure scripting with hopefully less obscure failure outcomes for a long time. This is not new, right? We're applying some predictive and neural net based, machine learning techniques to it. So, I give the example of hierarchical storage management. We've been for years, the problem has been in place, and solutions have been fielded to make sure you fetch the right data for the next part of the calculation. So it's not that different. But the question is, let's go back to the original thesis of the webinar, right? Is AI useful in managing HPC? I think absolutely yes. But is it AI in the sense of machines thinking for you? Arguably, no.
It's an interesting take on that, Alan. Thank you. Fernando, do you have something you wanted to add? So you come off mute before.
No, I was saying that we're a source of chaos. We're not really a source of truth. And there's not a lot of people spending a lot of time rebalancing data. We're still in especially now in large language models, we're still in the realm of dump everything and the kitchen sink into something and hope it comes out. And until we start to refine our data and rebalance our data, we're not going to get better answers. We're just going to continue to see the kinds of answers that you would expect if you asked, 1,000 people on the street.
Absolutely. We want to throw the question back up. We have a few questions to get to.
So I think this question is in response to my statement earlier about HPC being about distributed memory. And just in case that is it, to be clear, what that means in my experience isn't any particular technology about distributing the memory. It's not a large unified but distributed memory space. It's a partitioned memory space that you then let processes speak into each other's memory with RDMA, remote direct memory access, usually over some kind of fabric using MPI, or in other cases, some kind of PGAS or GasNet system. So that is what I think the answer to this is. But I'm not familiar with using Plan 9 to create a RAMFS that you would then share with a control node.
Yeah, but points for recognizing the abbreviation.
True.
I didn't know that it was. I don't know that I'd seen it written the other way around, but it was at least enough to make me confirm. And okay, yes, I haven't run Plan 9 myself though.
You certainly know where the name comes from.
Oh yes.
Oh, good.
Now we all have to know, Alan, because I don't.
Really?
It's Plan 9 from
Oh, it's
user
a
space.
famous old black and white science fiction movie, Plan 9 from Outer Space.
I'm going to go back and rewatch it. I hadn't even thought of that movie in so long. It's not even to go back and watch it. What if you can stream that? What are the odds?
I have a friend who lost years to Plan 9. So
we have another question.
Okay, I like it. Sylvie, thanks for watching and writing in a question. So maybe, Fernando, we'll start with you. How is ChatGPT used and involved in HPC in your experience?
So I don't have a HPC specific example, but it's a possibility for HPC. We just wrote a blog over at Voltron Data, the startup that I'm at now, where one of my engineers in my group augmented data. The data set that we use is a very common open data set, which is the IMDb open data set. So list of movies, stars, right, stuff like that. And what they did is they added a column and then used ChatGPT to give a synopsis of each movie. And then in that column, basically each movie now got augmented, or at least the entire data set got augmented with that. And I was thinking about how we could do that with any other language model, because, if we take the perspective of AI is compression and we can compress other kinds of data, we could get richer data sets that have, extra features added on to these data set that we can use then to compute on. Is it going to be, great? Is it going to be 100% correct? I'm sure that if we went deep down and looked at the synopsis of each movie, it wasn't going to be perfect. But it's a preview of what we can do with augmenting data sets, especially data sets that have been historically, lacking. I can think of examples in projects that I've been in healthcare where you have missing data maybe those data we can have a better model by completing some data with like demographic information or address or city, some sort of expectation of where that person might live based on other things that are within those data. So maybe we might have state missing, but we have the city, stuff like that. And I can see us getting a better, more complete data than leaving it with nulls and then removing them completely because I've got nulls, right?
It's very cool. Thank you. I haven't thought about it that way. Forrest, I know you
Yeah,
have
so
thoughts
it's
on
actually-
ChatGPT. Sorry, Alan, go ahead.
So it's easier to answer the question in the other order, right? How is HPC used in these kinds of algorithms? Going back to
So how is it
the
used?
sales technician's response, how would you like it to be?
So what is HPC's role in ChatGPT right now? Forrest.
It would be everything.
Yeah, bulk processing, right?
Yeah, I mean everything. It's Chat GPT exists probably in some way, shape, or form as between 1 to maybe half a dozen single files sitting on some system out there that something is running inference on, and that file is almost assuredly created, that model, based on heavy computation on GPUs. You can look at their partnership with Azure, I think, to bring more cloud computing into that whole project. Another example that's not GPT related, but just is kind of emblematic, is that Tesla runs a 5,000 node HPC system called Dojo with a whole bunch of custom silicon that they have in it called the Dojo chip that just sits there and dedicatedly trains AI. So at the moment, not only are we seeing the massive repurposing of things like GPUs, when we have, 8, 16 cores on the system, it's much more efficient to not be using, multi-threaded, pipelined, highly sophisticated CPU cores to do tiny little, basically multiply sum operations over and over again. It's much more efficient to do the thousands, millions of those that we need to do on the thousands of cores in a GPU. And so the GPU, like you said, Alan, has become this kind of generic computing device for a lot of different workloads, not only just AI, for all kinds of different workloads. But something interesting about AI is we're seeing a lot of development, like novel engineering in HPC, around creating devices beyond the GPU that are ultimately a GPU-like architecture, a whole bunch of little tiny cores sitting on a chip, but that are essentially dedicatedly made to just train AI. And so overall, yeah, we see, like I said, the GPU has become, the de facto standard in the AI world for what you do your AI training on. And those are mostly involved within the purview of HPC systems. And like I said, not only that, but the entire industry of HPC is in like a technological renaissance at the moment, trying to build the Cerebrus, the Habana, all these different dedicated little AI chips. So it's just like it's huge. It is. The industries are completely intertwined, like you said, Fernando. You can't really differentiate the two of them at this point. They're everything AI that you see is powered by an HPC system, ultimately in one way, shape, or form.
Right. We should probably make the distinction. Sometimes you see the criticism in the media about every time you type a chat GPT query, you're using up so much carbon or something. That part doesn't use processing. It's the part you're talking about, Forrest, which is the training and the inference and the developing of the models, where a lot of computer science goes on. People, run on our GPUs to develop these algorithms, and then when they get a good one, they think they train it. So when you actually just type a query, you're not burning a lot of carbon. You're just basically doing a web search among a database search in the results. So you shouldn't feel too guilty about asking it to draw a new picture for you or something.
Thank you, Alan. Jonathan, before I ask my next question.
Yeah, I don't have much insight or experience in how ChatGPT is used in HPC today. I mean, we've done mundane things like using it as a glorified search engine for config file syntax and things like that, or helping us to develop containers in containerization languages that, or definition languages that we have maybe less experience in. But that's pretty well understood. I did have one idea though, as the conversation was happening. So I acknowledged I've been critical is probably too strong. I've been skeptical of attempts to use general machine learning for fault tolerance, or sorry, like fault prediction and failure prediction and avoidance in HPC systems before. Not because I think it's a bad idea, but I've seen multiple projects targeted at that and none of them come to anything. And I do think, like Alan said, it's largely a data issue. But in my experience, it's also just been a putting the right people on an issue. I've experienced it as a side project of a systems team, or a purely academic experience that's not collaborative with a systems team. So I think there would be value in continuing to pursue that, either at a commercial level as a product, or as a joint research effort that has a bit more interaction than I've seen before. But I was thinking, we mostly experience GPT and its ilk as a conversational system, or at most it generating something that you would generate and now you don't have to. But I would be interested how effective it would be, and I don't know, I'm not an AI researcher, but I would be interested how effective it would be to train it on machine log data, or maybe even machine telemetry data, and then have it predict future log telemetry or log data, and then use that prediction to highlight divergences from the expectation. And I think most of these systems, most AI systems, are best thought of as a tool to enhance, an existing operation, something operators will do. And there's so much data. If you get all this telemetry data out of a BMC, like Alan was saying, and now what do you do with it? You need something that's going to help call out the important information out of that. And that's what I would be really interested to see. Not necessarily for it to take automated action, though maybe eventually that would make, there are some areas where that's already happening. But at the very least, to start maybe as an evolved grep that's showing you these are the things that diverged from what we expected, or that, more than some error bars expectation on either side of it. These are log messages that are divergent from the norm, and someone needs to take a look at them. That could be really interesting.
Yeah, I
That
think
would be very cool.
the general statement I want to make about that is, if you have a closed form system, I don't know exactly how to phrase it mathematically or with that kind of language, but if you have something that's a closed form, like Forrest mentions, writing set and awk scripts, think anything like that where there's a complicated step to be done, but it's completely within a set of existing examples. Or in your example, it departs from the existing examples. Those, I think, are solvable problems, and that's where I think the short-term win is. Fernanda has been typing in our chat, and she made the interesting point that that AI is basically compression. You want to expand on that, so to speak?
I think that's the thing that gave me a light bulb moment about 3-4 years ago, when somebody mentioned that AI is compression. And then there was actually a chat in our company's Slack, where somebody had presented a paper just this year, not just a few months back, where they had used gzip as essentially their model, and they were able to query it and do things with it as if it were an AI model that they built. So interesting that that we keep talking about AI as some sort of revolution, but I think in the end we're going to find it's a lot simpler than that. It's just trying to get things closer together, and just go on in that next little node in a graph, and it's just a really giant graph that we don't know what it looks like inside, but it's able to just kind of make leaps and bounds in those little nodes and a giant graph, and then tell us an answer. And whether or not it takes a wrong path, sometimes it just it depends on the kind of prompt that you put, or even how you word your prompt will take you a different path altogether.
So Fernando, are you saying that this is going to be like virtualization was and then containerization was, where we were doing it on mainframes years before we had any kind of virtualization, but it's the new thing?
It's the new thing, exactly. But I think, I don't know, it made AI to me feel more mundane. It's just a fancier way to do compression that's not a deterministic algorithm.
Thank you. Do we have another question that came in? From Art.
How will the economics change? Well, they already have. It's the dickens to try to get a GPU these days.
Have you seen the prices of GPUs?
Yeah, and let's be clear, it's all driven by the fact that the major cloud providers made massive investments in huge amounts of hardware because of anticipation of this AI need. So it's already changed the economics by making the parts scarcer. In terms of on-prem versus cloud, listen, I always say that when someone invents another form of transportation, you don't stop using the previous forms of transportation. You change the balance of how you use them, maybe. But flying cars may come along, and you will probably still have bicycles and trains and stuff. So how does that apply to AI and ML? It's another application of HPC. It's what Fernando's been saying. We've been saying as a group. You need HPC to solve these problems. Apart from the part shortage, I don't actually see any, first order change to the balance of how you use this stuff. Lots of researchers, here and at other universities use the local systems. The clouds are still as expensive as they were. That's why they bought all that hardware to sell you time on. So I don't see it changing the balance myself.
I want to reframe this question though, because I want to challenge Arthur's comment that the innovation is being driven by an AI and ML. HPC is what drove AI and ML. It was putting down Titan and having a project with NVIDIA to put those same math libraries, same linear algebra libraries that were running old-timey AI ML frameworks that were sort of okay. And then we put them on GPUs. And then somebody said, I could use the same BLAS, LAPACK, whatever math library it is that they originally put in there, and they can substitute it for GPUs. And that was what exploded AI. So the innovation came from HPC. And we've known this for years. We're sort of this, we're in this field where people think we're old-timey field. Oh, you're still doing Fortran, but we continue to drive innovation, and we continue to be left behind as if the innovation is not being driven by us, but passing us by. AI isn't doing anything to change what we're doing. We're doing a lot to change AI, and I wish more people would appreciate the kinds of deep, algorithmic work that we're putting into scaling all of that stuff. I mean, even like Horovod, right? Horovod was the first scalable framework for AI, for training, right? That the driving company built. It was built on MPI. We built these tools. We're the ones that are driving this kind of innovation. A lot of stuff that's running today, even in a large hyperscaler, still using TCP. They're not using, the sorts of communication frameworks that we've built in HPC. We're the ones driving those innovations. NVIDIA is hiring people from our field. Lots of the hyperscalers are hiring HPC people. In fact, we're struggling in lots of places and labs and whatnot for HPC people. We're the ones driving this innovation. AI is a consequence of HPC. It's not driving HPC. Anyway, that's my soapbox.
I don't even know how you follow that up. I mean, that's like a great way to end. Yeah, exactly. Mic drop.
I'm sorry, we're done now.
Oh, that was awesome. Thank you, Fernando. It's a great perspective. I really don't even know how to follow that up because that was perfect.
I'm sorry.
No,
Well, I'll follow it up with a link because I absolutely agree with everything Fernando said. So if you're curious how to learn these, I love the old-timey AI ML method. I just did a picture of 1890s AI ML here. But there's a reference that I put in our chat that maybe someone can put up in the notes from Andrew Ng's Stanford Computer Science 229 course last spring. It's a PDF of his lecture notes, and just is a absolutely great, precise, covering all these basic techniques, including the ones we started this conversation with. What do you mean by neural nets? What do you mean by machine learning? What are the various forms of predictive algorithms? So I wish I could come up with an inspiring, but AI will someday be a thinking, conscious counterpart. All I know is if that day ever comes, then all those prove you're not a robot captchas. We're going to have some explaining to do.
Yes, no kidding. Brandy, you mentioned a blog earlier from a colleague recently. Did you want to post a link to that?
Did I mention it? No, I mentioned that paper. Are we talking about that?
Nope, I thought early on there was another blog that someone that you work with had posted.
Oh, right. Oh, yeah, I can do that.
If you want to share that, we can post that
in
one
the show
too.
notes.
Yeah.
Yeah.
Be great. Thank you. Well, we are getting close on time, and I think Fernando wrapped it up perfectly. So I will give everybody the option to say something if you want to, but I don't know that you're going to top that. Jonathan's not on mute.
Sure. So the only thing that this kind of still resonating with me, Alan has challenged here repeatedly the kind of notion or what we expect of AI systems that we build and how we conceptualize them and what they're capable of. And this is a little bit off topic here, but I like to use that as a reflection of what we're actually doing when we think and we conceptualize. And the more capable we make our machines, the more we understand about what it is that we're doing that's different. And I look forward to continuing to be challenged in how we think and conceptualize the world as we compare it to the machines we build. I think it's a really interesting opportunity to learn more about ourselves.
Thank you, Jonathan. Anyone else before Rose wraps us up here?
No, thanks for letting me start with my criticisms, because I think it allowed us to go in the direction of what is it actually good for. And
Absolutely.
we've only just scratched the surface. There's a tremendous number of application areas, and Sturgeon's revelation, right? 95% of everything is crap. So yeah, 95% of AI is crap, but that's par for the course. Right? So we're looking for the good stuff, and there are lots of very clever people doing really great work. I don't want to diss them at all.
Absolutely.
Yeah. Good point. Forrest, we've had conversations about this before, and I brought it up to him. I was like, so do we need to be afraid? Right? Because there is AI is going to take over. This is the one thing you should be afraid of. And there's a lot of that kind of chat. And Fernando, you just said it so well. And it was one of the things that Forrest really said. He's like, well, you have to remember that it's people that are creating these algorithms, right? And so you got to take it back and realize that we are creating this the way that it is. So I don't know, maybe if you wanted to rephrase that in your own words, Forrest, I think you said it better.
People are generating the data. These AI models and types of methods that we have, and if we look at the show notes, Andrew Yang's lecture notes, these are all statistical methods that have been around for a long time. There's nothing really new about AI other than speed. Speed is what made it possible. The increase in memory is what made it possible. The capacity of systems and nodes is what made it possible. Even the interconnect can be slow right now, and it's still making it possible. The slight speed up, data collection ability, digitalization of data. That's what made AI possible. There's nothing really new here. It is a convergence of many things that it makes it more possible today. So I think we need to be a little bit less scared of AI, a little bit more skeptical that it can give us any new insights or new innovation. It might speed up the innovations that would have happened anyway.
I agree completely. It's mostly an imitation engine in the end. And just like, Fernanda, a lot of these techniques have been known since like the 60s, 70s, 80s. They were researching these things. And it's only just been with massive storage and computation that we've been able to actually research and act on them. So yeah, like I said, in a post 1 year after GPT or so, ChatGPT is out. We're all still here and stuff. So yeah, it's definitely not, the boogeyman that it's turned out to be. Like I said, it's mostly just collections of techniques that we finally have the resources to be able to apply to in the end.
But we could get innovation if we can get better data. And that's the next level. Right now, it's dump everything in the kitchen sink. Next level is going to be more discerning about your data, be more discerning about the balance of your data. And again, to reference again, Andrew Yang, and I think I referenced him the last time I was here, is his whole premise now, his whole startup now is better data. That you don't need behemoth models. You can do better with smaller data sets, and you can actually do a lot better in terms of supporting, say, industrial applications where you have very low signal to noise ratio. Then let's move on to the next stage. Like, the novelty is great. We can chat with these robots and sound pretty human, but let's move to the useful part of this stage now.
True.
Take that. That's a quote. We're going to make that into a little short.
Shit.
Yeah,
Like all kinds of
great place
t-shirts
to wrap
coming out
it
of
up.
today.
Yeah, a lot of t-shirts. I think a lot of nice snippets for your little snippet series. What do you call it? You can
The
go
shorts?
and get
The shorts.
the shorts. Yeah, they're great.
Yeah.
Snippet series.
Absolutely.
I like that, Alan.
There you
See, we just are on fire today.
Keep going.
Oh my God, you guys.
Okay.
Thank you so much. Super fun conversation. I know that we could probably talk for another few hours about this, but appreciate your time. Thanks for being here. And make sure that you like and that you subscribe. Put in any questions that you have. Follow us all over the place. Reach out to CIQ. We're happy to chat with you more about everything HPC and get all of your systems supported and all the cool things that we do. We love you very much. We'll see you here, same time, same place next week. Bye.
Thank you, everyone.
Bye, everyone.